What's that you got there? Looks really good.
It's the new Robert Sorby TurnMaster.
All right, you can tell me about it?
Yeah, it's got several unique features, suitable for wood turners of all levels, including anyone that's never turned before. There are 3 options of cutters and a patented 3-position indexable working head, allowing for shear scraping as well as traditional scraping. The 3 materials are high-speed steel, titanium nitride coated high-speed steel and tungsten carbide.
So why you got 3 different types of steel?
Good question. Tungsten carbide is the hardest of the 3 with excellent wear resistance.
So that means I don't need to sharpen it very often?
You don't need to sharpen it at all. It can be sharpened, but you do need specialist equipment to sharpen it on.
Wow, it's amazing. Lasts forever then?
Well, not quite forever, but you will get many turned items out of it before you have to replace the cutter.
So when it's blunt, I just chuck it away and buy a new one?
That's right, yeah.
The tungsten carbide works so well. Why do I need the other 2 choices of material?
Another good question. High-speed steel has good wear resistance and it's easily sharpened on traditional grindstones, pro-edge sharpening machine and many others. High-speed steel will produce a much finer and sharper edge than tungsten carbide will, so you will get a much better finish from it. That's basically because high-speed steel has a finer grain structure than carbide. I'll show you on a diagram. Any tool steel will only sharpen as sharp as the grain structure will allow. What do I mean by that? Tungsten carbide is actually not a solid metal at all. It's 50% tungsten, 50% carbide with a cobalt filler. So to look at the grain structure blown up thousands of times, the grain structure will look something like this. Anything in between these crystals is filler and not actually a cutting material. So you'll see from that, the sharpest you'll ever get that is the size of the grain structure. So if you imagine that as footballs, as an example, if we now look at high-speed steel has a much finer structure. Compared to the carbide footballs, this would be more like a golf ball in size, and therefore the sharpest that you will ever get that is 4 times sharper than the carbide.
So what's the difference in sharpening when you're turning?
A sharp edge will always be easier to turn. It'll produce a better finish on your turned item, and it's just a lot easier to use.
So there's many plus points for both carbide and high speed?
Absolutely, yeah. If you're machining exotic timbers, high silica content, very abrasive timbers, carbide is ideal and will outperform high-speed steel on roughing. If you're looking for a fine finish with clean detail, less sanding, then high-speed steel would be the choice.
Well, they sound like 2 really good choices. But what about the titanium nitride?
Yeah, the titanium nitride will basically enhance the high-speed steel. It puts a hard cutting face onto the high-speed steel, much harder than the high-speed steel, at about 90 Rockwell, and will extend the cutting life.
So we'd still sharpen it the same way as normal high-speed steel?
Absolutely, it can be sharpened on traditional equipment just the same as high-speed steel can.
Surely when it's sharpened, the coating will just be removed and you'll be left with high-speed steel?
No, not at all. I'll try and explain. If we take a traditional scraper, and then we add the plasma bonded titanium coat, it's the top face that is the cutting face. So no matter how many times you grind your cutting edge back, you will always be cutting with the titanium coated face.
Oh, it's explained it a lot better, and I know what you mean. So can you tell me a bit more about the head?
Certainly. The unique cutting head is able to hold many different sizes and shapes of cutter. There are 7 high-speed steel tips available, 7 of the titanium nitride and 3 of the tungsten carbide. All the cutters fit onto the unique head, held securely in place with the specific shape. These are all held in place with a high tensile torque screw rather than traditional Allen type screw. The other plus point to the tool, you probably noticed that there's a flat on the back to keep the tool flat and level. This keeps the cutter, head and the tool in the same plane. To enable us to shear scrape, the head has 3 indexable positions, one to the left as well as one to the right.
What's shear scraping?
Shear scraping gives you a much better finish and allows you to shear through the fibres of the timber rather than chopping out the fibres. We'll go to the lathe and I can show that. If we look at this piece of wood between centres, you'll see that the grain runs more or less parallel straight down the piece of wood. If we look at a traditional type of scraper, this is the same handle and parallel with that grain, and will tend to tear the grain out. So traditional scraping would be square across, and this will very efficiently remove material very quickly. We'll see from that although it's removed the material very quickly, the finish is not good at all. So if we put the tool into shear scraping mode, slacken the head, index it to the right, retighten the head, and now the same cut but shear scraping. The cutter is now shearing through the fibres of the grain. The difference should speak for itself.
Our finish is wonderful.
So again, in traditional scraping mode, in order to remove material, in shear scraping mode, in order to slice through the grain to give that very important finish. The cutter is now shearing through the fibres of the grain. The difference should speak for itself.
Our finish is wonderful.
Again, in traditional scraping mode, material can be moved very rapidly. Although that leaves a reasonable finish, this can be vastly improved by switching to shear scraping mode. So with the head handle to the right, shearing through the fibres of the timber. Again, the all-important finishing cut. Will give you an almost perfect finish.
That's an amazing finish.
And that's the Robert Sorby TurnMaster.